so we're not talking, right? I can answer that question if we have time at the end, or just come visit me in the morning or during lunch. So that's okay. So we're not talking, right? Right, Les? We're not talking. Yes, Lily. If it's an emergency, absolutely. If it's not, let's just learn the lesson, okay? Okay. But if it becomes, sometimes I need to drink water and it's an emergency, if you need it, go for it. But like for me, I need to have it because I'm talking so much. Okay, so I know the titles for these lessons are a little weird because we're using a different book right now. You can put the date, which is the 18th, January 18th, 2024. If you want to give it a title so it's easy to refer to, call it Power to a Power. And I'll explain what I mean by that. Power to a power. Nope, we don't need to comment on that. Okay? No comment. Power to a power. And just like all the other lessons, they're going to start out pretty basic, then they're going to get super ugly. But I promise that you have this whole toolbox of exponent property tricks. And we're just going to use all of the tricks of that toolbox, all of the tools in that toolbox, and we're going to do it. Okay? So, I'm not crazy about this, so I'm going to give you my own example, okay? What if we have 3 squared to the 4th power? I know you guys have already worked on these properties, so you might already know the trick. Are you guys thinking about the trick of what to do with the exponents? Oh, you're not?
I think I know how to do it. I think I do.
Okay, yeah, Faith, you tell me what you...
2 multiplied with 2 and 4.
Yeah, that's the trick. I just said, you already know the trick. Oh, man. No, that's good. You guys are supposed to know the trick.
I actually was just looking at the bottom.
Okay. Cheating. All right. What I want to show you is that if this whole thing is to the 4th power, what does that look like if I write it out? What does that look like? 3 squared times what?
3.
Times itself. Times itself. Times itself.
So that would be 3 times 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 3.
Yeah, you could really write it out. Or you could go, well, I actually know a trick. We already learned a trick for when the bases are the same and they're being multiplied. What do we do with the exponents?
You just add them up.
You add them up. So it would be 2 plus 2 plus 2 plus 2. How many times are we adding them?
4.
We're adding them 4 times, which brings us to the trick.
Oh.
If what we're really doing is multiplying it times itself 4 times, then the exponent is really 2 4 times, right? So the simple trick is when a power is being raised to a power, or I like to say, which is not a correct math term at all, I like to say if the exponent is being exponented. It's not really a verb, but I made it that way. But you could also say a power being raised to a power. It's just there 4 times total. So you just do 2 times 4. When you have a power to a power, your exponents are multiplied. Thanks. Look up, please. Everybody look up here. Doesn't concern you. Power to a power, multiply your exponents. Is anybody writing this down? Power to a power, multiply your exponents. Or if you want to write it in my silly terms, if your exponent is being exponented, multiply your exponents. If the power is being raised to a power, multiply your exponents. Jacob, did you have a question?
I remember, like literally yesterday, I thought we added,
Mm-hmm. That's when your bases are being multiplied. Your same bases are being multiplied. We add the exponents, which would be 2 plus 2 plus 2 plus 2. So that'd be 8. But the shortcut is if your base and power is actually being exponented. We haven't seen this yet. This is brand new. Where there's something with an exponent that has an exponent. It's like an exponent of an exponent. That is brand new in terms of me teaching the lessons from this book. I know you guys did it in your property sheet with Miss Leeds. Okay. So all of that to say, the trick of the trade is to simply multiply your exponents when the exponent is being exponented. Let's look at these little examples here. 5 to the 4th squared. What do we do with our exponents? Multiply them. Because 5 to the 4th squared is 5 to the 4th times itself. And Jacob, that's where you would say, well, if the bases are the same and they're being multiplied, then I can add the exponents. But the quick way to do it is if the base and the exponent are being exponented, then multiply, because you have 4 twice. 4 times 2 is 8. Yeah.
Is that just it? Is that all of them just do?
Does that sound like something that would be it? Do you usually learn one thing and then I say, that's it, everybody sit around for the next 20 minutes?
I thought we were gonna do like different examples or something.
Yeah, I mean, if you let me continue, I will. Can I continue?
Yeah.
Okay, thanks. All right, so I was actually just gonna go to this one, see how there's like more on the page over here. So m to the 3rd to the 5th power. What do we do with our exponents? Multiply them. Super simple, right? That's it, we're done. No, I'm just kidding. There's a lot more, okay? Oh, look, ugly little rational exponents. Rational meaning fraction exponents. And it looks weird because this 3 is bigger than this 3 over 2, but it's because they had to squeeze the numbers down to get it into a rational exponent. If this is being raised to the 3rd power, what do we do with the exponents? Multiply them. So we have a to the 3 over 2 power times 3 over 1. Why did I put my 3 over 1? Because I'm multiplying fractions. So that would be a to the 9 over 2. Am I done? Yeah, that's as far as we can take that guy. Let's look over here. It's just like that one, except it's even easier because since you have a rational exponent being raised to a rational exponent and you're just multiplying those exponents, you're just multiplying fractions, multiply across. If you can reduce, reduce, but in this case, we can't. So 1/2 times 3 over 5 is 3 over 10. X to the 3 over 10 power. That's it for this part. We haven't even gotten to example 1 yet, okay? That was the preview of what we're going to learn. Still have 23 minutes.
I meant like.
It's okay. I'm not like upset about it. I'm just encouraging you to, instead of asking me if there's more, just wait like 2.5 seconds and see if I keep talking. Okay? I'm actually gonna skip to the got it because we just kind of like went over it. These are super simple. You can try them on your own. And then we'll go over them together. Just do A, B, C, and D. They're all the way at the top here. A, B, C, and D. If you want to call me over to check them, I can. And then we're gonna move on to the next example. There's no talking. If you need help, call me over.
No.
Mm-hmm. Yeah. Hold on. Do C and D again. And remember, what are we doing with our exponents? You know? Yeah. Good. All right. The exponent is being exponented. Jacob, did you get it? Did you understand C and D? Okay, you can go if you understand it. Just hurry, okay? You can go at the end of class if you're still thirsty, okay? Next time, bring a water bottle to class.
Okay.
The thirst that you're feeling will remind you of how important it is to bring a water bottle to class. All right, is everybody paying attention? Angus, are you getting any of this down? Oh, okay. Some of it? Okay, good. All right, so p to the 5th to the 4th power, what's that?
P to the 20th.
P to the 20th, and somebody noticed, well, if the 4 is in here and the 5's out there, but you're still multiplying your exponents, isn't that gonna give you the same answer?
Yeah.
Yeah. So it's the same answer. What about this one?
E to the 1/8.
Yep, p to the 1/8, then what about this one?
P to the 1/8.
The 1/8, very good, any questions?
Just like,
Yeah,
so it's kind of like the rule of multiplication.
the commutative property of multiplication, yes, it's kind of like that.
Kind of. I almost keep changing.
It's like, it's the same idea as, like, what that is not the same thing, but it's the same idea, if that makes sense.
Same.
Okay, you're gonna start to get ugly, this is not even as close to how ugly it's going to get. So pay attention to this, so that when they get super ugly, you're ready, okay? Pencils are in your hand. And you've already written this down.
Oh.
Speedy Fizz.
So again, it's looking weird because 3 is an exponent, right?
Mm-hmm.
-2 is an exponent. 5/2 is an exponent, but the 5/2 is like written smaller, so it looks kind of weird. It's like, well, are they all exponents? Yeah, it's just that they had to smush that 5/2 as a fraction into an exponent spot. Yeah.
Is -2 an exponent?
Yes, the -2 is an exponent, even though it looks bigger than the 5/2. It's the 5/2 is an exponent and the -2 is an exponent. Now, I'm gonna write PEMDAS over here because we are going to definitely always be paying attention to order of operations. Because what 2 operations are happening here? Yeah.
Multiplication.
Yeah, and
Exponents.
yes, very good.
But
Multiplication and
But exponents comes first according to
the exponents come first. Yes. So even though you might look at these and see that the y's are the same base, and you're like, well, then can't I add these? Well, if this wasn't here, then sure, that's what we would do. But what Carmine is noticing is, yeah, that multiplication is technically there, but you're not actually supposed to multiply them because the exponent comes first. Then you can take that answer and set it to be multiplied times y/3. Thanks. Can you wake up? Do you need to like walk around or something? I don't know. Whatever you need to do, just stay awake, okay? Pencil in your hand for writing this down. The more you write, the more you'll stay awake. Okay. So, if I am exponenting an exponent, what do I do with my exponents? Multiply them. So that's 5/2 times -2/1, which would be what?
-10/2.
Right.
negative.
Yep, I usually cancel out if I can, so that would be a -5, right? -10/2 would reduce down to -5. I know the book does it that way. I like to cancel before I multiply if possible. What's that?
Why is it even negative? Yeah, but we're multiplying the 5 by a positive, 1, 5 positive 1.
No, when these 2's cancel out, they become this is a -2, so you
Can
would,
cancel out the negative.
Hold on, I get it.
okay. So it's 5 times a -1, which is -5. So that's our new exponent for this y. So we still have y to the third to start off. Then we have y to the -5. Now, we're on to the multiplication step. If we're multiplying these same bases, Faith, what do we get? Or tell me what to do.
-15. That was probably wrong. But I had a question.
It's okay, it is wrong, but it's okay. You're,
Parentheses.
Oh.
Would it still be in parentheses? Because you just did y to the third power and then y.
it's a really good question. Let me show you this. What's 2 cubed?
6.
8.
8. Because it's 2 times 2 times 2. Should the 8 be in parentheses? No. Can it be in parentheses if it wants to be?
Yeah.
Sure. If it wants that extra little hug of protection. Yeah. Or like if I have like 2 times 3 and then I get like 6, you can put that in parentheses too. So to answer your question, no, it doesn't need to be in parentheses anymore. The parentheses were showing that this exponent belongs to this term. And once you simplify it, it can break it out of the parentheses. But if you wanted to put it in parentheses, it is just showing that these are being multiplied together, which also is being shown by them being just next to each other. So if these are being multiplied, what are we, there you go, what are we,
adding.
we're adding. Good, are we done?
Yes.
Not quite. You're like, that was me over here. I said, yes, I want to be done with this. Let's move on and forget about it.
Too bad yourself.
All right, y to the -2. Angelina, what's the last step that we have to do?
You need to get rid of the negative.
Yep, got a bad attitude. Send it downstairs to be more positive, to do some positive thinking, some positive affirmations. Okay, are we done?
Yes.
Yes, now we're done. But only with that example, and then I'm gonna move on, okay?
I was talking
I'm
about like
just,
getting
I'm
different
messing with
topics.
you. I'm messing with you. It's okay. Allow me to have a little bit of fun, even though I started out cranky. We're making good time, so I'm getting less cranky, but don't push it. I might get more cranky again. All right, I want you guys to do these A, B, and C. I'm gonna give you 2 minutes. If you only get A done, that's totally fine. Just do as much as you can in 2 minutes. Hey Siri, set a timer for 2 minutes. Yeah. So 16 and 4 is a multiple.
So if I just put a negative,
And you have to do it 2 plus 6 and 4 is going to be a
negative 4.
You have put in 4 and then negative. What am I doing here? Okay. Very good. All right, I'm gonna, wait. Okay. Yep, very good.
Wait, just like jacket.
You're right there, Jacob. That's good, but then, that attitude is
Is this fine?
So, let's see how you got this. So, first reduce that. 15 over 3 is what? No. 5. And then you have w to the negative 2 times w to the fifth. What do you do with your exponents? Add them up. All right, that was 2 minutes. If you didn't finish, that's totally fine.
We're gonna get 8.
We're gonna find out because I'm gonna give everybody the answers, okay? My point is, I can't go around individually anymore because that would take up way too much time, but everybody gets the answers. This one, you have to multiply 6 times negative 4. So this becomes x to the negative 24th power. So you have x squared times x to the negative 24, which means you have to add your exponents now, which would be x to the negative 22. Are we done?
No.
I'll tell you, sometimes I feel done, and then I realize, oh, I gotta do one more thing that's got a bad attitude, so I'm gonna put it in the denominator with a positive attitude. Okay? Good?
Yeah.
B, multiply your exponents, put the 3 over 1, cancel out your 3's, and we get w to the 5th power. If you got w to the 15 over 3, that's fine. Just make sure you divide 15 by 3 to reduce it to 5. So we have w to the negative 2nd power times w to the 5th power. What do we do with our exponents now? Add them up. W to the 3rd power. Are we done? Yes, it's got a nice little positive attitude. And the last one over here, yeah, some of you guys got to this. So we have a negative 5 to the negative half power. I'm going to slap that over 1. Multiply a negative times a negative is a positive. So s to the 5 over 2 power times s to the 3 over 2. Gotta love those common denoms, which would be s to the 8 over 2, which is s to the 4. Did anybody get
That's
s to
my
the 8
mistake.
over 2 and leave it? Because that's okay.
Nope, I got,
It's not the final. Is that what you got? Okay.
No.
You did it totally right. Just remember that anything that can be reduced or divided should be.
I got 15 over 4 because I'm multiplying it.
Okay, so that's not good, but practice is progress. So, all right, we're going to move on to the next example because I still have more to go. Just messing with you. You know I'm just messing with you, right? All right. All right, get ready for this. I'm gonna just skip to this, okay, ready? Here we have something that doesn't actually look all that different, but it's very different than what we've been doing.
What?
And the reason it's different, Binks, everybody look up here. The reason it's different is because this exponent doesn't just belong to the variable. It also belongs to the coefficient because this term, 3x, is in parentheses with the exponent. So that exponent belongs to the entire term. So that literally means 3x times 3x times 3x times 3x. How many times is 3 being multiplied times
4.
itself? 4 times. 3 to the 4th power. It's kind of like, and again, this is my term, not the book's term, it's kind of like you're distributing the exponent to both parts of the term, or all parts.
So wait,
of
it's
the
basically a
term.
backwards distributive.
Kind of. It's because that exponent belongs to every term inside.
2 birds, 1
So it's 3 to the 4th power and x to the 4th power. So we can simplify the 3 to the 4th power by popping it into our calculator. 3 to the power of 4 is 81. And then x to the power of 4 is x to the power of 4. It's as simple as you can get. So 81 times x to the power of 4.
I knew it.
Okay. Okay. It's getting ugly over here. It's gonna get so hideous. You're not even gonna believe it. It's ugly, but we're gonna get through it. This exponent 3 over 2, it belongs to the b. It also belongs to the 4. So it's 4 to the 3 over 2 power times b to the 3 over 2 power. Can anything here be simplified?
Yes.
Yes, we gotta go into our exponent toolbox and say, wait, doesn't this mean that the denominator is actually the root of the number? And then you have to use the numerator as your exponent?
So it would just be 2/3.
Nope. So what's the square root of 4?
Two.
2. And then what's 2 to the 3rd power?
So it's 8.
8. So this is 8. And then what's b to the 3 over 2?
B to 3rd.
b to the 3 over 2. That's it. For now.
What?
And then we have more.
What?
That's it for that one.
Oh, flip.
Try got it 3.
So they both have custody.
And I'm going to tell you about B and C real quick. If the exponent that belongs to everything is negative, before you distribute that negative exponent, send it to the dungeon with everything. Then distribute it. I'm going to set this one up for you, okay? This one is one like we just did. But this one is like, oh, so doesn't this mean 2 to the negative 4th power and times z to the negative 4th power?
No.
Yes, it does. But it's going to get really complicated
can't
when
put
you
that
have
all in
so
one.
many negative exponents. So just keep it together. I heard some whispering or something going on. Keep it together and send it all to the basement in parentheses to get a positive attitude. So you see how everything got sent to the basement to get a positive attitude. Then
we distribute.
Then you can distribute, which is probably not the right term. Then you can distribute the 4 as the exponent for 2 and as the exponent for z. Okay, do A, B, and C.
Then you can
Please set a timer for 2 minutes.
Okay.
You got them already? You need help? Would you rather me do them with you?
Yes. No.
At least A.
I don't get it. Like, these look nothing like the last one we did. I want to try it on my own.
Okay. So the 3, don't listen to me if you want to do it on your own, okay? If you want to get some hints, look up here. This exponent 3 belongs to the 7 and to the m to the 9. What this is, I'm gonna write this out. You don't have to do it this way because this is the long way to do it. If this whole thing is being cubed, that means 7m to the 9th is being multiplied times itself 3 times. That's a lot, right? That's 7 times 7 times 7, which is 7 cubed. And then m to the 9th times m to the 9th times m to the 9th. Isn't that m to the 27th power? Because 9 times 3 is 27. 27th power. So all you have to do now is plug 7 cubed into your calculator. What part is hard? Did you understand the example that I did right before this? Okay. I'll be right with you. Okay, so when we did this, it made sense to you to allow this exponent 4 to be the exponent for the base 3, right? 3 to the 4th, and then x to the 4th. Now, the only difference with the try it problem that you just had is that the exponent already had an exponent and then was being exponented. So we're actually using our tool that we learned today about when an exponent is being exponented. You multiply your exponents. So the 7 is being cubed and the m to the 9th is also being cubed, which means we have to multiply our exponents. It's totally fine if it's not sinking in yet. It might take a little while. Just allow yourself to listen, and if you're not processing it right now, that's okay. Because we always have it on video, or come in for lunch, breakfast, not breakfast. Come in for breakfast, this isn't like Cracker Barrel. Okay, all right, so over here, we've already sent it to the basement. Shh. We've already sent it to the basement, and do not leave because I have a homework sheet for you. I've already sent it to the basement, and now we can just solve. 2 to the 4th power, you can do that in your calculator if you want to, but you might have it memorized. What's 2 to the 4th power?
16.
16. And z to the 4th power is z to the 4th. Again, we're going to send this to the basement, the whole thing. 3g to the 4th, in parentheses, to the positive 2. Now we're going to simplify that. 3 squared is 9. G to the 4th squared is g to the 8th. Okay. Nobody? Because 3 to the 2nd power, 3 squared.
Okay.
Don't move.
Show me on the video.
Okay. No. Here's what I want. Nobody move. I need to give you your homework. If I can keep you after class, I will. No talking, no moving. This says it's due Thursday, but that's not right because today's Thursday. We're a day behind and that's okay. We're gonna go as slow as we need to go. So just rewrite it to say due Friday. There's some very important instructions about this. Okay, is everybody listening?
Yep.
This goes to number 51. You are not gonna go all the way to 51. You're gonna go all the way to 37. You're gonna complete every odd number all the way through 37, including 37, and then you're gonna stop. We'll do the rest as an activity in class tomorrow. I'm not by my grade notes, so I might not remember that, so you might wanna catch me when I'm not.
Wait, skip the odd ones?
No.
Skip the odd ones.
Okay. So I'll say it again. Change the due date to Friday. And then circle number 37 and make a little note at the top that says complete all the way through 37 and stop. And then also circle where I wrote here, odds only, okay? So you're just gonna do like 11, 13, 15, 17, all the way through 37 and then stop. It's due tomorrow. I will let you go in just a second. Did I tell you that we're not gonna have the open note quiz tomorrow? That'll be Monday. Did we talk about that yet?
No.
Okay, I shifted things because I still have another lesson to teach you before I can give you that quiz. Don't move. I think that's it. There's a homework help video on YouTube right now if you want help with this homework. Okay, you guys.
What is this?